Hello, what is power? Power is the rate per unit time at which electrical energy is transferred. Now, to understand this concept, let's think of those three machines. 1, the fan, 2, the hair dryer, and 3, the dryer machine. Which one uses the most power? If you think of it, the most power is used by the dryer machine. Why? Because if we go back to the definition, we said it's the rate per unit time, so each instant, each time at which electrical energy is transferred. Which one do you think at some instant would use the highest energy? The rate of energy, which I would say dryer. So power is like the effort that each machine need to start, or like how much electricity at that moment this machine needs. This is power. Okay, power is has the unit watts. For the fan, normally the fan works between 55 to 100 watts. You can say on average 75 watts. The hair dryer uses on average between 400 and 1800. Maybe the average is 1200 watts. And the dryer, the clothes dryer, it uses between 1800 and 5000 watts. On average 3,500 watts. So this is the highest. If we use the entire machine for only 1 second, this one, then here you'd pay the most. Now normally I want you to differentiate between the energy and the power. Energy is when you multiply power by time. That means you want to know like the entire interval through 3 hours or 24 hours, how much this machine used, how much this machine used. But if you are only concerned about some instant, then this is called power. Now we took example last time. We said for those two machines to use the same energy, we know that this has higher power. So like the common sense say, if they work for the same time, then this machine would use more energy. But if we wanna equal the energy here, then since this is higher power, right, we said E equal P times T. Since P in the dryer is high, then if we use less time, we might get the same energy as the fan. And this what we proved last time. If we use the fan for 2 hours, we are using 150 watt hour. And if we're using the hair dryer for 7.5 minutes, we're using the same amount of watt hour. So again, power is at some instant how much energy is used at that instant. And for sure the hair dryer at some instant would use more than the fan, while the clothes dryer would use more than both those two machines. Now let's look at the graphs. If I have the power time graph, then at some instant the reading would be the power. Here I wrote a note, power at some instant, while energy is the power at the entire time interval. So all of this is the energy, which is over time, power times time. While energy, if he gave me the graph of energy versus time, then if I divide energy over time, E over T, that would give you power. It's the rate per unit, and this is the derivative. So always remember, division in these formulas means derivative. If I have the energy, if I take the derivative of energy, and derivative means the slope, like how steep, how inclined this graph is. The more inclined is the more power. So if the graph is like this shape, this is so much, this is more inclined than this one, right? Or like this is less inclined. So this has a higher power, this has a lower power, if this is the graph of what? Of energy versus time. Okay, now the equations, two equations, is if we want to relate power to voltage and current, it's P equal V times I. Normally in houses the voltage is 120 volts, and each machine work on some ampere. Some machines, let's say, need 6 amperes, then power would be 120 times 6 is 7,200, right? If I'm not mistaken, 7,200 watts. Okay, if I want to relate power to energy, we already said it's the derivative of energy, or it's the rate of energy over time. That was the entire definitions. In next video we'll talk about the dependent and independent source, and we will finish with node and loop definitions. So stay with us.